we've got breaking developments on one of the most significant astronomical discoveries of 2025. An interstellar visitor is racing through our solar system right now, and what scientists are finding is rewriting everything we thought we knew about comets from other star systems. I'm talking about 3I Atlas, and the data coming in is absolutely mind-blowing. This isn't just another space rock. This is a messenger from another world, carrying secrets that could be billions of years old. Let me take you back to July 1st, 2025. The Atlas Survey Telescope in Chile, part of NASA's asteroid detection network, spotted something unusual moving through the constellation Sagittarius. At first, astronomers weren't even sure what they were looking at. This faint object, appearing as just a 20th magnitude dot of light, was about 420 million miles from the Sun, roughly 4.5 times the distance from Earth to our star. But here's where things get incredible. When astronomers calculated the trajectory of this object, they discovered it was following a hyperbolic path, meaning it wasn't bound by our Sun's gravity. This thing came from interstellar space. Within hours of the discovery, observatories around the world confirmed what many thought was impossible. We had our third interstellar visitor, officially designated 3I Atlas. The 3 means it's the third confirmed object from beyond our solar system, following the mysterious cigar-shaped Oumuamua in 2017 and comet 2I Borisov in 2019. But 3I Atlas was already breaking the rules. Initial brightness calculations suggested this thing was massive, possibly 20 kilometers across. But something didn't add up. The object was too bright for its distance if it was just reflecting sunlight like a typical rocky asteroid. This suggested we were looking at something with its own fuzzy atmosphere. A comet developing its characteristic coma as solar heat began vaporizing its icy surface. By July the 2nd, additional observations confirmed the presence of a small coma and even hints of a tail. We weren't just dealing with any interstellar visitor. We had our first active interstellar comet since Borisov. Fast forward to August 6, 2025. The James Webb Space Telescope, humanity's most powerful space observatory, turned its advanced near-infrared spectrograph toward 3 Atlas. What it found sent shockwaves through the astronomical community. Webb discovered that 3I Atlas has an extreme carbon dioxide-dominated atmosphere, with surprisingly little water vapor, the complete opposite of what we see in comets from our solar system. This wasn't just unusual, it was unprecedented. Think about what this means. Every comet we've studied from our solar system has been rich in water ice. When they approach the Sun, that water ice vaporizes, creating the spectacular tails and fuzzy atmospheres we associate with these cosmic snowballs. But this visitor from another star system is telling us a completely different story about how comets form. Around other stars, the research team analyzing Webb's data found that the comet's coma, that fuzzy atmosphere surrounding it, is dominated by carbon dioxide gas, with only small amounts of water ice, water vapor, carbon monoxide, and carbonyl sulfide. This chemical signature suggests 3IR Atlas formed in an incredibly cold region of its original star system, colder than anything we see in our outer solar system. It's like finding a desert plant in the Arctic. It tells us the environment where it grew up was fundamentally different from what we're used to. Dr. Martin Cordiner, leading the Webb observations, explained that this discovery forces us to reconsider our models of how planetary systems form. If comets around other stars can have such radically different chemistry, it suggests the diversity of worlds beyond our solar system is far greater than we imagined. While Webb was analyzing the chemistry, the Hubble Space Telescope was capturing the sharpest images ever taken of an interstellar comet. On July 21, 2025, Hubble revealed 3I Atlas, surrounded by a teardrop-shaped cocoon of dust streaming away from its nucleus. The image was breathtaking, showing material being ejected from the sun-warmed side of the comet and swept back by solar radiation pressure. But here's what stunned astronomers. Hubble's observations showed the comet's nucleus is much smaller than initially calculated. Instead of that massive 20-kilometer monster, 3I Atlas measures somewhere between 440 meters and 5.6 kilometers across, with the most likely size being less than 1 kilometer. That's smaller than many city blocks. Yet this tiny object is producing an explosive, rapidly expanding atmosphere. This created a new mystery. How can such a small object produce such an extensive coma? Pre-discovery observations from the Vera Rubin Observatory showed the atmosphere had grown from 13,040 kilometers to 18,660 kilometers in just 11 days. Between June and July, that's incredibly rapid expansion for such a small nucleus, like watching a marble suddenly surrounded by a cloud the size of Earth. The dust analysis revealed something equally fascinating. Hubble's detailed observations showed that small dust grains are being ejected from the nucleus at speeds of 22 meters per second, while larger particles move at just 2 meters per second. This creates a complex layered structure in the comet's atmosphere, almost like geological strata, but made of gas and dust in space. Scientists estimate that 3I Atlas is losing about 6 kilograms of small dust particles every second. For such a small object, this represents an incredibly high activity level. It's like a cosmic pressure cooker, releasing material at rates that challenge our understanding of how comets should behave. By late August, something remarkable happened. 3I Atlas grew a spectacular tail. The Gemini South Telescope in Chile captured stunning images on August 27th, showing the comet had developed the characteristic streaming tail that makes comets so beautiful in the night sky. The team of scientists and students who captured these images described feeling both excitement and wonder at watching this interstellar visitor transform before their eyes. But this wasn't just any tail. Early observations showed what appeared to be a sunward plume, material seemingly flowing toward the sun rather than away from it, which seems to defy basic physics. Don't worry, the comet isn't actually breaking the laws of physics. This anti-tail effect is a viewing geometry illusion caused by our perspective from Earth. When you're looking at a thin sheet of dust particles edge on, and that sheet extends both toward and away from the sun, it can create the optical illusion of material flowing sunward. The geometry becomes even more complex. When you consider 3I Atlas follows a nearly retrograde orbit inclined, at about 5 degrees to the plane where most planets orbit. This unusual orientation maximizes these perspective effects as viewed from Earth, creating visual phenomena that naturally raise eyebrows and feed speculation. By early September, observers noticed something even more striking. 3I Atlas began glowing green. This eerie coloration comes from dicarbon molecules fluorescing under solar ultraviolet radiation. Green comets aren't unprecedented, but the timing and intensity of 3I Atlas's green glow appeared earlier and stronger than expected based on its distance from the sun and unusual chemical composition. Here's where the story gets mind-blowing. Research led by Matthew Hopkins and his international team suggests 3I Atlas could be one of the oldest objects ever observed, potentially older than our entire solar system. Their analysis indicates this comet likely originated from the Milky Way's thick disk, a population of ancient stars that formed during our galaxy's cosmic noon, billions of years ago. Professor Chris Lintott from Oxford University, who co-authored the study, put it perfectly. This is an object from a part of the galaxy we've never seen up close before. We think there's a 2/3 chance this comet is older than the solar system, and that it's been drifting through interstellar space ever since. Think about that for a moment. This comet might have been wandering between the stars for 7 billion years, since before Earth even existed. It formed around an ancient star when our galaxy was young, was somehow ejected from its home system, and has been drifting through the cosmic void ever since. It's carrying information about conditions in the early Milky Way that we can't get any other way. The thick disk population represents stars and their planetary systems from an era when the galaxy contained different proportions of heavy elements. Stars in this population are metal poor compared to our sun, meaning the raw materials available for planet and comet formation were fundamentally different. If 3I Atlas really did form in this ancient stellar environment, its unusual chemistry starts to make perfect sense. Hopkins' research team used sophisticated galactic dynamics models to trace 3I Atlas's likely origin. Their calculations suggest this comet has been traveling through space for potentially billions of years, surviving countless close encounters with other stars, molecular clouds, and the general chaos of galactic evolution. The fact that it's still intact and active tells us something profound about the resilience of these ancient objects. The astronomical community has responded to 3I Atlas with unprecedented coordination. NASA has mobilized an extraordinary array of space telescopes and missions to study this visitor, including Hubble, Webb, TESS, SWIFT, SPHEREx, the Perseverance Mars rover, Mars Reconnaissance Orbiter, Curiosity rover, Europa Clipper, JUICE, Lucy, Psyche, Parker Solar Probe, Punch, and the ESA NASA SOHO Observatory. 3i Atlas will reach its closest approach to the Sun on October 30th, 2025, at a distance of 1.4 astronomical units, just inside Mars's orbit. This perihelion passage represents the comet's moment of maximum activity, when solar heating will drive off the most gas and dust, potentially creating spectacular displays visible from Earth. But there's a catch. After September, 3i Atlas will disappear behind the Sun from Earth's perspective, creating what astronomers call superior conjunction. This means ground-based telescopes won't be able to observe the comet during its most active period. It'll be lost in the Sun's glare. The comet won't reappear in Earth's skies until early December 2025, by which time it will be heading away from the Sun and becoming less active. This creates a critical observation window. We have just weeks left to study this visitor before it becomes too close to the Sun to observe safely from Earth. Every night of clear skies becomes precious for astronomers trying to gather as much data as possible before 3i Atlas disappears. The timing is both frustrating and fascinating. Superior conjunction provides a natural test of how much we can learn about an object when it's not directly visible. The spacecraft observations from Mars and other vantage points will become crucial during this period, potentially providing our only views of 3i Atlas at maximum activity. One of the most intriguing aspects of 3i Atlas involves how it polarizes light. When sunlight reflects off the dust particles in the comet's coma, the orientation of the light waves carries information about the size, shape, and composition of those particles. Polarimetric observations by the Very Large Telescope, Nordic Optical Telescope, and Röschen Observatory revealed that 3i Atlas exhibits unusually high degrees of negative polarization at small phase angles. This technical measurement translates to a remarkable finding. The dust around 3i Atlas scatters light in ways unlike any previously studied comet, asteroid, or other solar system object. The polarization characteristics suggest the dust grains have optical properties that don't match natural materials we're familiar with, possibly due to processing during the comet's long journey through interstellar space. Cosmic ray bombardment over millions or billions of years could alter the surface chemistry of dust grains, creating exotic textures and compositions. Alternatively, the dust might have formed under conditions so different from our solar system that its fundamental properties are unlike anything in our local environment. These measurements represent some of the most precise diagnostic data we have about 3i Atlas's true nature. The discovery of 3i Atlas comes at a perfect time in astronomical history. The upcoming Vera C. Rubin Observatory is predicted to discover between 5 and 50 interstellar objects once it begins full operations. 3i Atlas might be just the beginning of a new era in astronomy where we regularly study visitors from other star systems. Each of these objects is like a free sample delivery from distant stellar neighborhoods, carrying chemical fingerprints and formation, histories we could never access otherwise. Instead of spending billions of dollars and decades of travel time to visit other star systems, these ancient wanderers come to us, bringing their secrets within range of our most powerful telescopes. The implications extend far beyond just studying individual comets. If objects like 3i Atlas are common, they could play important roles in spreading organic molecules and even potentially life throughout the galaxy. These interstellar messengers might be one of the mechanisms by which the galaxy mixes and shares its chemical inventory across vast distances. The study of 3i Atlas is proving that our models of comet formation need major updates. If comets around other stars can be so chemically different from our own, it suggests planetary system formation is far more diverse than we imagined. The carbon dioxide-rich chemistry, unusual polarization properties, and ancient age of 3i Atlas are expanding our understanding of what's possible in the universe. For dedicated amateur astronomers with reasonably sized telescopes, 3i Atlas should remain visible through late 2025 and early 2026, weather permitting. Professional observatories will continue intensive monitoring as it approaches perihelion and eventually emerges from behind the Sun. Every day of observation is precious because once 3i Atlas completes its swing around our Sun, it will head back into interstellar space on its hyperbolic trajectory, never to return. This is literally a once-in-a-lifetime opportunity to study material from another star system up close. The data being collected now will keep scientists busy for years, potentially revolutionizing our understanding of comet formation, planetary system evolution, and the chemical diversity of objects throughout our galaxy. Atlas represents more than just an unusual space rock. It's a messenger from cosmic deep time, carrying secrets from the ancient Milky Way that we're only just beginning to decode. As we watch this visitor race through our solar system, we're witnessing a direct connection to stellar environments billions of years old and trillions of miles away. And the best part, this is probably just the first of many such visitors we'll discover in the coming decades. The universe just got a lot more interesting,